In this video, we are going to revise some questions from Mathematics Paper 2 for 2018. Now, this one is for internal. Now, let's look at the first question from section A. Given that the matrix A has these elements 4, -5, 1, and 2, and B has 8, Y, 3, and 5. Now, Roman number 1, find the value of Y for which the determinant of A and B are equal. Okay, so let us write the matrix for B. So from the B, we can see that we will have a missing number denoted by our Y. So now for us to find the missing value denoted by Y, first we need to find the determinant of B. So how can we find the determinant of B? We'll use this concept where we have been given a condition that the determinant of A is equal to the determinant of B. And from the matrix A, we can see that the elements, all the elements are given. And since all the 4 elements are given, we can find the determinant of matrix A. Okay, so let's also write matrix A here. Okay, so now for us to proceed by finding the value, first we need to find the matrix, the determinant of matrix B. Now, before we find the determinant of matrix B, let's first find the determinant of matrix A. So the determinant of matrix A is equal to, so here we are going to multiply the major diagonal, so it is 4 multiplied by 2. Then we subtract the product of the elements of the minor diagonal. So the minor diagonal is 1 multiplied by -5. So the determinant of matrix A is equal to 4 times 2 is 8. Then here we can see that we have the negative times negative, so we get positive. 1 times 5 is 5. So if we add, the determinant of matrix A is equal to 13. Now, since the determinant of matrix A is equal to 13, even determinant of matrix B will be equal to 13, since we are saying the determinant of matrix A and determinant of matrix B are equal. So we'll say, therefore, determinant of matrix B is equal to 13. Now, since we have the determinant for matrix B, we can now proceed by finding the value of Y. So we'll use the same principle. Determinant is equal to, so here the major diagonal we have 8 and 5, so multiply 8 times 5 minus, then for the minor diagonal we have 3 and Y, so here we multiply 3 times Y. Now, where there is determinant, we substitute with 13 is equal to 8 times 5 is 40 minus 3 times Y is 3Y. So let's correct the like terms. So the like terms are 13 and 40. So the 40 will shift to this side, giving us 13 minus 40 is equal to negative 3Y. Then positive 13 minus 40 will give us negative 27 is equal to negative 3Y over negative 3 over negative 3. Then Y is equal to 3 into 27 is 9, and we are going to get the positive 9, since the two numbers that are dividing have the same sign. So we've found the value of Y. So let us write the matrix for B with its now actual number. So here we have 8, then Y is 9, 3, 5. Now, since we have the actual matrix with its elements, let's now find the inverse of B. So inverse of B is B raised to the power -1. Then the formula is equal to 1 over determinant multiplied by its adjoint. So we need to find the adjoint of matrix B. So adjoint of matrix B is equal to, So for you to find the adjoint of a given matrix, for the major diagonal, you just interchange the position of elements. So 8 and 5 will swap each other. So here our 5 will be written here, then our 8 will go here. Then for the minor diagonal, you don't swap the numbers, but you change the signs. So positive 3, here we'll have negative 3, then here we have negative 9. So our final answer is 1 over the determinant is 13, then the adjoint is 5, negative 9, negative 3, 8. So this is how you can find the answers to a question like this one. So now we move on to question B. A small bag contains 6 black and 9 green pens of the same type. 2 pens are taken at random, one after the other, from the bag without replacement. Calculate the probability that both pens are black, Roman number 1. Then Roman number 2 are of different colors. Now we are not taught to find the tree diagram, but in questions like this one, I prefer we draw a tree diagram so that we may have a clear picture. Now from this bag, we can see that we only have 2 outcomes. There is the chance of picking a black pen or black pens, and also there is a chance of picking a green. Now since we only have 2 outcomes, then we are going to have 2 branches. So let's look at the tree diagram. So this is our tree diagram. So we'll say this is our first pick. Then since two pens were picked without replacement, so we are going to have the second pick. Now from this tree diagram, you are able to see that we have 2 branches for each. So since we have 2 branches, the branches must correspond with the outcomes that we have. So in our case, we have 2 outcomes, black and green. So here we'll put black, then here we'll put green. So the same pattern, even here the same pattern like this. Then from there we can indicate here we'll have our first pick, then here we'll have our second pick. Now let's look at the first before we look at without replacement. So the first part here, you just have to indicate the total number of each outcome. So let's look at we have 6 black pens over the total 6 plus 9 is 15. So on the first part you don't subtract. Then here we are going to have 9 divided by 15. So that is what you need to do with the first part. So you can look at these 2 numbers. We have not done any subtraction. Now since we have been given a condition that they were picked randomly one after the other without replacement, so we need to make an assumption that the first pen that was picked was black without replacement. So if we pick 1 black, how many black pens will remain? So we are expecting to have 5 black pens. Then even the total should reduce to 14 since 1 is picked without replacement. Then if we assume black is picked, then green must not change. So the green should be 9 over 14. So what is meant by this point? So what this point is, we are saying we have 6 black pens, then we have 9 green pens. Now we are saying we are assuming that we have picked 1 black. So how many black will remain? We are going to have 5. Then how many green? The green is still intact, 9. So if we add 5 plus 9, we are getting 14. This is the total that we are getting. So that is what it means by without replacement. Now for the other branch, For the other branch, we are going to assume now it was a green picked. So we assume it was a green picked, so the 9 green pens will remain 80 over 14. Then here we are going to have 6 over 15. So to some people it may be confusing. How come we said 5 over 14? And where is this 6 over 14 coming from? Remember, for this branch here, we assumed it was black picked. For the second part here, you need to assume it was the other one picked. So if we assume it was green picked, the black should remain the total, meaning we need to have 6 over, then the total 14. So that is the picture here. Then for the possible outcomes here, we can see that we are going to have black, so this is BB. Then for this one, we are going to have black, green. Then for this one, we are going to get green, black. Then for this one, you can see that we are going to get green. Okay. Now, since we have this tree diagram, we can now go back to our first Roman numeral number 1. So the Roman numeral number 1, we want the probability that both are black. So we'll say 2 black. So from the 2 black, we can just look at this possible outcome where we have BB. So this is our answer. So now let's look at the first, this B is corresponding with this number here. So it is 6 over 15. Then times the second B is 5 over 14. So if we multiply 6 times 5, we will get 30 over 15 times 14. This will give us 210. So if we cancel this 0, we can reduce. So we have 3 over 21. Then 3 into 3 is 1, 3 into 7. So the probability that 2 of these pens are of the same color, which is black, is 1 over 7. Now let's look at now of different colors. So of different colors, we are looking at these 2 possible outcomes, because this is where we have different colors. Because the first one, two pens of the same color, black. Then the last one, 2 pens of the same color, which is green. So we need these 2 probabilities. So we'll say probability, we'll just say different colors. So this is what we are going to say. Then we'll get B, G plus G, B. Okay, let's look at the first one. The first one, our B is 6 over 14. Then the pattern that you need to know is the first letter represents the total before you do the subtraction. So this B indicates this value. So the first letter, like the first letter B, indicates before the subtraction was done. So it's 6 over the total 15 times it. But the second one, the total must reduce to 14. That's a pattern. So green here, we can see we have 9 over 14. So we have 9 over 14 plus even here, the first green here must represent the total before the subtraction was made. So this is our 9 over 15. Multiply by, then our blue, this one, it is 6 over 14. Okay, so 6 times 9, that is 6 times 9, that is 54. So here we have 54 over 210 plus another 54 over 210. So if we add 54 plus 54, we are getting 108. Then over 210. So let's reduce. So let's see, find the common number. So common number, let's use 2. 2 into 108 is 54. Over 2 into 210 is 105. So we can just leave our answer at this stage. If we want, we can still reduce this now one. We still have some numbers that are common, like 3. 3 can go into 54. Okay, let's just reduce this. So 3 into 5 is 1, remainder 2. 3 into 24 is 18, over 3 into 10 is 3, remainder 1. 3 into 15, so that is 35. So for 35, I'm sure there is no number that is common between the two numbers. So this is the probability of picking 2 pens of different colors. Okay, maybe let's look at how can we find the same answer. So what can we do? So what we can do is we can find the probability of picking 2 pens of the same color where we have black and green all together. So let's do this mathematics. So let's find the probability of picking these of the same color. So if we look at of the same color, we'll say, so probability, we'll just say same color. So for us to get same colors, we need to add probability of picking blue plus probability of picking green. So the first blue was 6 over 15 times 5 over, that is 14, plus the green. For us, for green we said this should be 9 over 15 times the other green should be 8 over 14. So let's do the math. So 6 times 5 is 30 over 15 times it's 210 plus 9 times 8 is 72 over 210. So 72 plus 30 is 102 over 210. So this is the probability of picking 2 pens of the same color. So what we can do is now let's subtract this from 1. So we can subtract that from 1, then it will be good to go. So now probability of having different colors will be 1 minus 102 over 210. So the lowest common denominator is 210. 1 into 210 is 210 times 1, that is 210, minus 10 into 210 into 210 is 1 times 102, that is 102. Then 210 minus 102 will give us 108 over 210. So if we reduce, 2 is common. 2 into 108 will give us 54 over 105. Then 3 into 5 is 1, remainder 2 into 24 is 18 over 3 into 10 is 3, remainder 1 into 15, 5. So we can see that we are getting the same value. So that's what you can do. You can find the probability of picking the same color, then you subtract that from 1, will also give you the probability of finding whatever that you are looking for of different colors. Okay, so now we move on to question 2a. Solve the equation 3x squared minus x minus 5 is equal to 0. So 3x squared minus x minus 5 is equal to 0. Then giving your answers correct to 2 decimal places. So this is a quadratic equation. So you can solve it using the quadratic formula or completing the square method. So let's use quadratic formula. So the coefficient of x squared is a, then the coefficient of x is just b, then the number without the letter is a constant. Then the formula is x is equal to minus b plus or minus, then the root of b squared minus 4ac divided by 2a. So let's look at the value of a. So the value of a is this one, which is positive 3. Then the value of b is negative 1 here. So that is negative 1. Then the value of c is negative 5. So let's do substitution. So x is equal to minus, the value of b is negative 1, plus or minus the square root. Here we are going to have negative 1 squared minus 4. Our a is positive 3, our c is negative 5. Everything divided by 2 times 3. So let's now simplify. Negative times negative, it's positive 1, plus or minus, then here negative 1 squared is just 1. Now we can see that we have this negative will multiply with this negative. So negative times negative, we get positive. Then 4 times 3 is 12. 12 times 5, that is 60, over 2 times 3 is 6. Then we can first simplify what we have under the square root. So 6 plus 1 is 6 over 6. Now we can find the square root of 61. So square root of 61 is giving me 7.81024967 divided by 6. Then upon reaching here, we are going to separate this into 2 equations. So the first equation will consist of the positive. So here we are going to have 1 plus 7.8102469676, and we'll do the same with the other one, but we will have minus. Okay, so let's deal with the first part here. So 7.8102496780 plus 1, I'm getting 8.81024967 over 6. Then if we divide by 6, then I'm getting 1.4683744946. Then since we are told to leave our answer correct to 2 decimal places, we just want 2 numbers after the decimal number. So we are going to have 1.4, but our 6 will become 7 since the number after 6 is greater than 7. Now let's look at the other part here. Here we are going to have negative 6.81024967 divided by 6. So negative 6.81024967 0.249676 divided by 6. So I'm getting about negative 1.13504163. Then our final answer, we just need 2 decimal places here, so negative 1.34. So these two are the two solutions for this equation. Now there is one more clarity that I would like to share with some of you. There are some of you that may have information about equation like this one, that the values of x should always be positive and negative. No, that's a misconception. You may have positive, you may have negative, you may have a positive and negative. So it depends the way the equation is. You have, I'm sure, drawn some quadratic functions in paper 1. You know the intercept. You may have where the x-intercept is negative, the other is positive, or you may have the two x-intercepts, they are positive. So in overall, what I'm saying is these two values can be positive, can be negative, can be positive or negative. So it depends with the question. Okay, so now we move on to question B. At Samilene College, 20 students studied at least one of the 3 subjects, mathematics, chemistry, and physics. All those who study chemistry also study mathematics. 3 students studied all the 3 subjects. 4 students studied mathematics only. 8 students studied chemistry, and 14 students studied mathematics. Draw a Venn diagram to illustrate this information. So for a question like this one, you need to be extra careful and you need to understand the key points from this question. So let's try to draw the Venn diagram. So the Venn diagram, we know we need to draw a rectangle. So this is our Venn diagram. Now under this Venn diagram, we are going to have 3 sets. Now from these 3 sets here, we know that we have the first point that we need to put into consideration is we have the intersection of all the 3 sets. So 3 students start all the 3 subjects. So we need these 3 sets to intersect at one point. Now let's look at what are we going to do for us to maintain the 20 students. So the key point here is for chemistry, we are told the 4 students study mathematics only. Okay, 8 students study chemistry and 14 students study mathematics. Now there is the first point here. All those who study chemistry, also study mathematics. All those who study chemistry also study mathematics. So from this statement, we can see that chemistry is the subset of mathematics. So what this means is we have the mathematics here, then the chemistry will be inside. Why? Because all those that studied chemistry also studied mathematics. So let's say we have, maybe let's try to have a picture. Let's say we have set A with elements such as 1, 2, 3, 4, 5. This is our set A. Then set B has the elements 3 and 4. So we can see that B is a subset of A. Why? Because the elements of B are found in set A. So if we are to draw this visually, we are going to have the set B inside. Why? The 3 and 4 elements are also part of set A. So the other 1, 2, even up to 5 will be like this. So this is the key point from what we are talking about here. So now let's try to draw this one. Now, so we are going to draw this one. This represents mathematics. So we have our maths here. Then inside we are going to have the subset, which is chemistry. Now we need to have the intersection of all the three sets. So the other subject, physics, will be like this. So this is our physics. Then we'll have our chemistry inside. Okay, so let's look at first the students that studied all the three. So 3 students. So here is the intersection of all the three. Why? 3 is part of chemistry, is part of physics, it is also part of mathematics. Okay, then let's move on to what else? 4 students. 4 students studies mathematics only. There is only. So the mathematics only is found in this region here. This is where our mathematics only is, because here is maths and physics. So the mathematics only is just found on this region. So we put 4 here. Then from there, let's look at this 8. So 8 students start chemistry. So from the 8 students, we have 3. So 8 minus 3, here we are going to have 5. So we are going to have 5. What else do we have? We have 14 students start mathematics. So from this 14, we have 4 that studied mathematics only. Then we have 5 that studied chemistry and mathematics. We have 3 that studied chemistry, mathematics, and physics. So we need to add these numbers. So 5 plus 4 is 9, plus 3, that is 12. 12 from 14 is 2. So here we are going to have the 2. Now let's look at the total numbers of these. So we have 4 plus 5, 9 plus 3, 12 plus this. So we have 14. Now the total number of the students, we have 20 students. So 20 students minus the 14, here we are going to have 6. So this is how we can draw a Venn diagram for a problem like this one. Now let's move on to Roman number 2. How many students start physics only? So for physics only, this is the region for physics only. So we can see that here we have 6. Then 2 subjects only. So we want for those that studied 2 subjects only. So here we can see this region, it's 2 subjects only, physics and mathematics. Then also this is the 2 subjects only, chemistry and mathematics. So it is 5 plus 2. So 5 plus 2 will give us 7. Then mathematics and physics but not chemistry. So mathematics and physics but not chemistry. So we remove the chemistry part. So we have 4 plus 2 plus 6. So this is giving us 12 students. So we move on to question 3. Here we have the integral part of calculus. So we are going to integrate this problem. So let's look at how do we integrate. So let's look at the problem. So what we are going to do is we have some terms like 2. 2 is a constant, so you need to add x to it. So the 2 becomes 2x. So the integration is just the reverse of the differential calculus. So 2 becomes 2x. Then for x, we can see x has the power of 1. You add 1 over 1 plus 1 minus x has a power of 2. So 2 plus 1 over 2 plus 1. Then evaluating from -1 to 2. And let's see what we can do for the inside party. Here we have 2x plus x. 1 plus 1 is 2 over 2, so here we have 1 over 2. Then minus, here we are going to have 1 over 2 plus 1 is 3 raised to the power x to the power 3, evaluating from -1 to 2. Then since we are done integrating, let's now write two brackets. So the first bracket will have the interval of 2. So this one will have a 2, then minus the same. So minus 3 raised to the power 3 raised to the power -1. Then we need to substitute. So 2 here where there is x. So this means that x is equal to 2. So here we need to substitute x with -1. Okay, so now let's see how we can simplify. So this one, 2 times 2 will give us 4, plus 2 times 2 squared is 4, times 1, that is 4 over 2, minus 2 raised to the power 3 is 2 times 2 times 2 times 2, 3 times, so we get 8 times 1 is 8 over 3. Let's minus. So 2 times -1 is, we get negative 2 here. Then we'll have -1 squared, we'll get positive 1 times 1, this is 1 over 2, minus 1 over 3, -1 raised to the power 3, so it's -1 times -1 times -1, which is -1. So if you cube a negative number, the final answer is always negative. So here we are going to have -1. Okay, so we'll continue from here. So here we have 4 plus, we can divide 2 into 4 is 2, minus 8 over 3. Then here we have -2 plus 1 over 2. So this negative times the -1, we get positive 1 over 3. So let's see how we can simplify it. So 4 plus 2, we here we have 6 minus 8 over 3. Here we can see we have -2, so over 1 plus 1 over 2 plus 1 over 3, since it's a fraction. So over 1, let's look for lowest common denominator. For the first party is 3, then we divide 1 into 3 is 3 times 6, that is 18, minus 3 into 3 is 1 times 8, that is 8, minus, let's look at the lowest common denominator for these three numbers is 6. Then 1 into 6 is 6 times the -2, that is -12, plus 2 into 6 is 3 times 1 is 3, plus 3 into 6 is 2 times 1, that is 2. From here, 18 minus 8 is 10 over 3. Then here we are going to do, so we'll say -12 plus 3 is -9 plus 2, that is -7 over 6. So it's 10 over 3. This negative will multiply with this negative, giving us positive 7 over 6. Then the lowest common denominator here is 6. 3 into 6 is 2 times 10, that is 20, plus 6 into 6 1 times 7, that is 7. So 20 plus 7, here we have 27 over 6. So we can reduce this, what number is common? 3 is common, so 3 into 27 is 9 over 3 into 60, that is 2. So 9 divided by 2 is just 4.5. So this is our final answer for this problem. So we move on to question B. Find the equation of the normal to the curve y is equal to x plus 4 over x at the point where x is equal to 4. So if we are to have this visually, if we have a curve, this is our curve, then this line that touches the curve at one point, this is the tangent. So we have the tangent here. Then the normal is a line that is perpendicular to the tangent at the point of contact. So this is our point of contact. So what you need to know about the point of contact is these three shares the coordinates at the point of contact. So the coordinates of the curve and of the tangent and of this, the normal, they are of the same at the point of contact. Now from the point of contact, you only have x is equal to 4. So what we are going to do is we'll first begin by, let's find y. So for us to find y, we use the original equation. So x plus 4 over x. So now since we have the x value is equal to 4, where there is x we put 4. So 4 plus 4 over 4. So y is equal to 4 plus 4 into 4 is 1. So y is equal to 5. So we have the 4 comma 5. So this is the x1, y1. Now the formula for the normal is that of the straight line. So y minus y1 is equal to open gradient, open bracket, x minus x1. Then for us to find this equation, we need the slope, which is the gradient. Now for us to find the gradient, first we are going to find the gradient of the curve by finding the first integral of this equation. So let's find the first integral. So the first integral is y is equal to x plus 4 over x. So now before you differentiate a given, not integral, sorry, you find first the first derivative. So not integral, sorry for that. So for us to find the differential, first we need to move the x to the numerator part. You can't differentiate whenever x is on the denominator part. So if we move x to the top, we are going to have 4 x raised to the power negative 1. So the sign of our x will change from positive to negative. Then from there we are going to differentiate. So this will be dy over dx is equal to, here x has the power 1, so we move the 1 to the front, then we subtract 1 minus 1. Then for this one we are going to have 4. We need to move this negative 1 to the front. We'll get negative 1x, then negative 1, like that. So let's continue. So we have dy over dx is equal to, here we are going to have x raised to the power 0, since 1 minus 1 is 0. Then this 4 will multiply with negative 1, giving us negative 4. Then x raised to the power negative 1 minus 1 is negative 2. So dy over dx is equal to x raised to the power 0 is 1 according to the indices. So it's 1 minus 4x raised to the power negative 2. Now after we are done differentiating, since we have a negative index here, we need to convert it into a positive by taking it back to the denominator part. But where there is dy over dx, we put the m for gradient. Then it's 1 minus 4 over x raised to the power 2. Now let's find the gradient. So the gradient that we are solving here is the gradient for the curve. So it's 1 minus 4 over what is the x. So from this one we can say that the x is equal to 4 squared. So gradient of the curve is equal to 1 minus 4 over 4 squared is 4 times 4, which is giving us 16. So if we reduce this, will give us 1 over 4 into 4 is 1, 4 into 16 is 4. So over 1, gradient is equal to, the lowest common denominator is 4. 1 into 4 is 4 times 1 is 4 minus 4 into 4 is 1 times it. So our gradient of the curve is equal to 3 over 4. Now, since we have found the gradient of the curve, what is the gradient of the tangent? So what you need to have in mind is the gradient of the curve is equal to the gradient of the tangent. So gradient of the curve is equal to the gradient of the tangent. Now we have the gradient of the tangent. Then how do we find the gradient of the normal? So for the normal, we are going to say gradient of the normal, it is just the reciprocal of the gradient of the tangent. So we are going to flip the fraction. So this will give us 4 over 3. Then you change the sign. If it's positive, you need to make this one negative. If it's negative, you need to make it a positive. So that is the pattern. So this is now the gradient that we are going to use here, since we are looking at the normal. So let's now simplify our answer. So 4 minus y1 is 5. Our gradient is negative 4 over 3. X minus our x1 is just 4. So let's get rid of the fraction. We'll multiply everything by 3. So the 3 will multiply by y. 3 times y is just 3y minus the second one. 3 times 5 is negative 15. Now this 3 will cancel with this 3, giving us negative 4. Then x minus 4. So 3y minus 15 is equal to negative 4 times x is negative 4x. Then negative 4 times negative 4 is positive 16. So let's now move this to this side. We have 3y is equal to negative 4x plus 16 plus 15. So 3y is equal to negative 4x plus 31. So we can leave our answer at this, or if you want, we can divide by 3, here by 3, also here by 3. So our final answer is y is equal to negative 4 over 3x plus 31 over 3. So this is the equation of the norm. So we will consider this video as the first part for mathematics paper 2 for 2018. So that's it for this video. Thanks for watching.